All right, welcome back. We are COMP301. That's Linux operating systems in the summer 2020 semester, and it's week 11. The only part of our broadcast, because we have a shortened week this week. We normally meet on Mondays and Thursdays, and this week we're only meeting today because of the long weekend Monday that just happened. So we're going to be talking about this array-oriented programming with NumPy. I think it's a great topic to go through, again from an organizational perspective, way ahead of lists, dictionaries, and tuples. We've already covered this, and Python functions. So we're more into the data science side this week again. And again, this is all, I would say, enrichment more than anything else, enrichment content or additional content for you guys who are interested in data science and machine learning eventually. If you're not, that's okay, because there's some great functionality that I'm offering here that you can use for Python. A couple of things to note is next week's lecture will be the last, or next week will be the last lectures. So that's lectures on Monday and Thursday of next week. And then the following week, there will be no lectures. What I'm going to do instead is do a review on the Monday. That's the last week of class, followed by I will open up the test that you will have a chance to complete for the entire week. It probably will be, I'm just letting you know, true, false, multiple choice type test this time around. It's going to encompass everything we've done on the Python side. Of course, it'll be open book, and you can use, I will heavily lean on all of the PowerPoint slides that I've given you, so that if you actually study the PowerPoint slides, you'll go through it and you'll be able to answer all the questions, I'm fairly certain, with a good degree of accuracy. And I think that's what I'm looking for the final test. So nice and easy. Again, you'll have a whole week to do it. I'll give you multiple attempts, probably 2 at minimum, to try it out, so to maximize your effort and to get you the best possible marks in this course, which is what I'm looking for everybody that takes my courses anyway. Okay, so that is the that is definitely my goal, and that's what we're doing. So even though we're talking about machine learning and stuff, I don't expect you to know everything about machine learning and data science and all that stuff. This is not the topic of the course. It's Python and Linux. We've done the Linux portion, and this is the Python portion, and I'm excited to do this with you guys because it's a good example of, getting you guys prepped and ready, just like I'm doing with my JavaScript course. I'm getting you guys prepped and ready for the next set of courses that are coming up in the following semester. So that's my goal for you guys. Remember, I'm a little different than some others in terms of I want to push you guys to learn more, but I'm also going to be as fair as possible, and I do apologize for the marking delay, but I'm going to be as fair as possible to make sure that you guys get the highest possible marks. And if you trust me, and normally students do every semester, I don't mess up. I don't mess around. I'm not trying to, to try and reduce your scores or anything like that. That's not my intention. It's really all about learning for me. That's my goal. So bear with me, and then if you can be patient, this semester's been very busy as normal. I will ensure that you get the top possible marks based on your effort. Okay, so I'm not looking at like, I'm going to bell curve it or anything like that. It's not about that for me. It's about, you kind of check mark all the things that I've asked you to do, and you're going to get the marks that I specify in your assignment rubric. All right, so everything that's in there. Okay, so that's just a little bit about where we are right now and what's happening. So next week, again, final instruction week. I'm hoping to do a little bit of machine learning with you next week if we can. We'll see how that goes. If not, I'll step back and do something else Python related. And I mean high level stuff that you have a chance to play around with, so you get your feet wet kind of thing when it comes to what it's like to do some really cool functions with Python. Today we're going to be talking about Pandas, which is a great library. It's one of the most popular libraries out there, I would say, in terms of data science and machine learning. And data science and machine learning are different. Data science is like big data, and machine learning is obviously using a little bit of AI to predict for prediction and classification reasons, right? So that's why we do it. And I always think about machine learning as, like I said to you guys before, as statistics on steroids, whereas data science is like another part of statistics, what we're going to be talking about today. So that is really where we are. So we're going to start with, again, like we said before, array-oriented, this idea of array-oriented programming with NumPy and pandas. Those two things. Pandas would be the machine learning or data science portion of it. But first, before we get into that, sorry, I'm just looking at the chat. Why is my block full within 1 hour for fall semester? When you mean full, are you talking about like to apply to or to register for my course? It's not fair. Yeah, I do apologize. I'm not sure why that is. But you know, you can, and I'm going to cover stuff the best way I can. But remember, if you're taking COMP301, and that's the next course in the series, which is going to be our course on web application development, then remember, I'm writing that course for you guys. So it doesn't matter if you have me or another instructor, you'll still have you know, the same course material, and that means there's a high probability that you're going to, you know, even if you watch the videos that I produce or anything like that, that you should be fine. You know, you can follow along and be pretty good. And the instructor, I haven't met with him yet, the other instructor that I know, but he is, apparently he's very versed in the mean stack and React and all that kind of stuff you guys will be learning next semester, so I think it'll be okay. Okay. I'm sorry I'm not an easy professor. Sorry, Joseph, I know I'm not easy. But I'm trying my best to give you guys some additional enrichment, like I said. Okay. So let's get into this. So I want to start by talking about assignment 4. And assignment 4, this is not my assignment. I keep thinking that this is still basic programming practice. So even though it's the sentence generator, this is like basic programming practice with Python continued, I would say. Okay? So I'm not asking you to do machine learning or data science or anything in here. This is the exact same assignment that everyone else is getting from all the other sections. I've just broken it down so that it's a little bit more understandable for you. Okay, that's what it is. So I've produced a PDF document that looks like this. This assignment is due the last week of class. That's Friday, August 21st, 2020 at midnight. It's been posted. It's worth 15% of your final grade. There are 60 points that I'm looking at, and mostly in the functionality piece, which we'll talk about. So what is this thing that you're going to make? You're going to be using a sentence generator, which is kind of interesting that I guess our course lead had set this up. And what it is there is a piece of code that you're going to be given that's already attached to this. I've already attached it for you. So let's take a look at that code. And I'm going to spin up my VM for a second, since we might as well do that. Because I want to describe, does this replace the final test? No, it doesn't. The final test is going to be true, false, multiple choice. So bear with me while we do this thing. Remember, there's 4 assignments, and there's a final test. I'm not going to kill you with additional quizzes. So whatever quizzes you've done already, I'm going to take all those quizzes, and you're going to get your maximum quiz mark from those things. And that's my goal for the quiz part. Okay, so hopefully, let's see if you guys can get this. So here's me. I'm on my Ubuntu VM. Logging in. You guys should be logging into your VM as well, whether you're using Ubuntu or Fedora. Remember that for assignment 3, which is due tomorrow at midnight, and assignment 4, which is going to be due a couple weeks out, everything should be done within the Linux environment, please. So please try not to do that. Wow, it's really loud here. Please try not to do that in Windows. That would be a mistake, because then you'd lose marks for that. Potentially not. Maybe I shouldn't accept it, is what the answer is, because it's really a Linux course. That's why the name of the course is Linux Operating Systems. So I'm going to give you this code in a second. I'm just going to make a brand new folder for today. We're going to call this folder COMP301. COMP301, and it's in the summer 2020 semester, and it's lesson 11. I'm going to include the default code for us in lesson 11 to play around with for assignment 4. And I'm just going to open up that folder. So I'm going to look at lesson 11. You see lesson 11 is empty right now, and that's good. I'm going to make a new file called generator.py. And the code that I'm going to grab is the code from the stuff that I've given you. All right, so where you can find that code online is if you actually open up the assignment details. So if I actually go there to the assignment details, you can download generator.py. All right, that's where it is, generator.py. I'm showing you this so that way you can do what I'm doing. I'm just pasting it here again, right, so that you can see the details when I go into it. And bear with me while I do that. I'm just going to copy paste from my Windows side to my copy paste from my Windows side to this is the code to the Linux side. Okay. Let's see if this actually does the paste. It does. Okay, so this is what you're going to get. Okay, I'm just looking at assignment 4 still, guys. I'm going to actually put this up with today's lesson because we're talking about assignment 4. Okay, so if we're going to run it the way it is, let's take a look. Let's do a read through. Whenever you look at a piece of code, for you, what you should do is read through what the code does and try and decipher it without running it first. Okay, so for example here, we can see we've got a doc string for the entire thing. We're importing random. So that's the random module. And you've got several variables. And just if you notice here, right, you have variables that look like this. What kind of variables are these that you're getting? You got round brackets, tuples or tuples. Absolutely. Joseph, I'm going to talk about, yeah, web is still coding. We're going to do coding. Linux is true, false, multiple choice because of, I need to switch it up for you guys. I don't want to kill you guys. Okay. All right. So these are all tuples. That means that you have articles. There's only 2 articles, a and the. There's nouns, boy, girl, bat, and ball. Verbs, hit, saw, and liked, and prepositions with and by. Okay, so that's what these things are. So group a bunch of tuples based on. Keep your file safe by backing up regularly. That we're going to use. Okay, so what happens is when we call the main function, this is the main function here, what should happen is number is a new variable. It's a local variable inside the main function that converts to integer my input. So example, it says enter the number of sentences. You're going to enter the number of sentences. You're going to get an input value. That value is going to be whatever you put in. It's going to convert it to an integer and store it in the number identifier variable. Then we're going to make a little for loop in a range. This is the default program that you're getting, right? Of number. So for example, if we say we want 4 sentences, we're going to do 0 to 3. 0, 1, 2, 3. That's what's going to be stored here. And each time we run through the for loop, it's going to call the sentence function. Sentence returns a noun phrase plus a space plus a verb phrase. Noun phrase is here. This is all functions, right? So we're going to get a random choice, random.choice, of articles. So random choice means grab a random object from the article's tuple, a or the, plus a space, plus a random choice from the nouns, boy, girl, bat, ball, one of these things, a, the, whatever you're going to get, okay? And that's what's going to give you the noun phrase. So that's the noun phrase plus the verb phrase. Verb phrase is going to take a random choice of verbs, hit, saw, liked, plus the noun phrase, right? Some other noun, again, plus the preposition phrase, okay, which is down here. So it's going to basically do a compound or combination of phrases that's going to create a sentence and return it here. That's what it should do. Let's run this code and see if it works. And main calls the main program. That's what it does. Okay. So if I was going to run this thing, if I said Python and then generator.py, then it should ask me for how many sentences. Let's say we want 3. And then when I enter it, it says, a bat saw the bat by the girl. Is that a proper sentence? Well, yes, but I mean, we can assume that, make a couple assumptions. One, this is garbage English, right? It's a subset of English, like it says in the assignment details, right? The boy hit a boy with the bat. Okay, the girl liked the ball by the bat. Okay, that's kind of weird. But you can see that it generates these random sentences, and they're all in caps, of course. So let's try it again, and let's try 5 sentences. So 5, a girl liked the bat by a boy. That's weird. A bat saw a bat. You know, you can see there's not a lot of choices here, right? We can add additional articles, nouns, and verbs and prepositions, so that way we can have more interesting sentences. Okay, but in general, that's how we build out this randomly generated sentences that make no sense. The ball hit the bat with the girl. That's weird, right? It doesn't make sense at all. A ball can't hit the bat with the girl, right? But that's what it does. That's what the sentences kind of are created that are random. So I'm gonna put this up on GitHub. Let's do this now. So again, what I would do with this is I would say, just like for you, it's git init, git add dot, git commit -m, and we'll say initial commit for today. And then I want to push to GitHub. I'm just going to create, I'm in my Linux VM here, and I'm going to create a new, let's go to Centennial. I'm going to create a new repo that's public. Okay. Here's a new repo that's public. I'm going to grab the last 2 lines of code here. I'm going to copy them. I'm going to go back to my Visual Studio Code, and I'm going to paste them if I can. Let's try that again. That didn't quite work. It works better on Windows, to be honest. Copy. Yeah. Woo! Okay, so we'll just type it out. Actually, see if I can just do one at a time. So copy and paste. Right click, paste. Okay, how about that? And git push -u origin master. Ta-da! It's up on the master branch. Great. And that means that this, if I refresh, is going to be good. Generator.py. So you have generator.py. I put it up on our latest lesson for you to try out. And so that's the first thing. And we're not going to use it as today's lesson. I'm just talking about it because I want you to know how it works, right? Because we're talking about the assignment. So that's what generator.py does. So we're going to use, it says, it kind of opens up here and it talks about how sentences in any language have a structure defined by a set of grammar rules, and we're just using the grammar rules here to produce random sentences. That's what this thing basically does. And now that's wonderful. My house is going to burn down again because people are cooking without a fan. All right. So one thing it says, task 1, it says modify the sentence generator program attached so that it inputs its vocabulary from a set of text files instead of tuples. That means that if I go back to here, to Ubuntu, which is here, right now what it does is it uses tuples, right? These tuples right here. And instead of using tuples, what it's asking for in the assignment document is don't use tuples, use a set of text files. For example, nouns.txt, verbs.txt, articles.txt, and prepositions.txt. So you're reading from text files in order for you to load stuff into tuples, okay, potentially. And it says hint, define a single function, a new function, get words. This function should expect a file name as an argument, and the function should open an input file with this name, define a temporary list, read words from the file, and add them to the list. And the function should then convert the list to a tuple and return the tuple. All right? Call the function with an actual file name to initialize each of the 4 variables in the vocabulary. Okay? I recommend, to make it more interesting, you add additional nouns, verbs, and articles and prepositions to make it more fun for yourself. Otherwise, you're going to be stuck with the ball, the girl, by, and with, and that's it. So kind of see if there's other things you can add in there to make it more interesting. Okay, that's what I recommend. So that's task 1. Task 2 is make the following modifications to the original sentence generator program. The preposition phrase is now optional. It can appear with a certain probability. Okay, so what does that mean? So if you go back to here, prepositions. Notice it says, I want to generate a sentence. The sentence has a noun phrase and a verb phrase. The noun phrase has an article and a noun, right? And then the verb phrase has a verb, noun phrase, which is up here, another noun phrase, and prepositions, a prepositional phrase. This prepositional phrase will only show up randomly. Sometimes yes, sometimes no. What do prepositions do? With, by, and so on. And the preposition phrase will not add an additional phrase at the end. That's what's going to happen. So how do you do that? So randomness in your verb choice, which makes it more interesting. So that's the prepositional phrase. A conjunction and second independent clause are optional. Example, the boy took a drink and the girl played baseball. Okay? So that is another optional, means random. Okay? The adjective, an adjective is optional. Optional, remember, an adjective means a description. Look up what these, if you guys don't know, and if you're not great at English, and even if you forgot, if you're an English speaker and you forgot what a conjunction is, what an adjective is, and so on, you should look it up. It's not that difficult. So think about what a conjunction is. It's like and or. That's that kind of something that joins 2 sentences together, right? Or sub-sentences, if you will. The boy took a drink and the girl played baseball. And is the conjunction, right? So it's optional. An adjective is optional. Adjectives describe words, right? So are nouns. So for example, the girl is a noun, kicked is the verb, the red ball is the noun, red is an adjective that describes the ball. Sorry for being an English teacher for a second. With a sore foot. Sore is an adjective that describes foot. Sore foot, right? So it's a modifier. That's what an adjective is. Modifies the noun to give it more meaning, more context. That's what it does, right? So do we have adjectives right now? Notice we have nouns, verbs, articles, and prepositions. The answer is no, right? So if I go back to here, right, we have articles, nouns, verbs, and prepositions. We don't have adjectives, and we don't have conjunctions. That's another thing we don't have. So you need to add 2 more things. Now, one thing that this part does, and again, I'm sticking with the document here, right? It says make the following modifications to the original sentence generator program. And it says you should add new variables for the sets of adjectives and conjunctions. Okay, those 2 things. Obviously, if we're reading from a file here, nouns, verbs, articles, and prepositions, these things here, you might as well put them in files too, adjectives and conjunctions. However, it does not specifically say that for task 2. So if you wanted to generate just tuples in your code, you could, but it doesn't make any sense. If you're already loading, you might as well make a couple more files, adjectives.txt and conjunctions.txt, and you're good to go. Okay? That's it. That's the assignment. I don't think it's a difficult one. I think you have a code base to start from. Really, here, the first part is I want to read stuff from files. Yay! That's not that difficult. And the second part is more interesting, where you're going to do some randomization. You're going to use random features, to randomly put words together and sentences together. Okay, so that's kind of cool. You're still going to describe stuff with a internal documentation if you need to in different places, and of course you must have some kind of doc string for your file and your classes and so on, if you're going to use classes at all, and put it up on GitHub. I think that's normal like before, and of course some kind of video presentation for your generator.py. You're just going to really think about your generator.py and what you've made changes to, describe it, and demonstrate it. That's all I'm looking for this. Okay, so that's really what it is. When we say a zip archive of your project folder, that was a question I just got on chat. What this means is I have a project folder, right? I've got this. Visual Studio creates a project. I open up a folder. What I mean is I want you to zip up everything in a specific folder. Let's suppose that this was a folder I did in Windows last day, as an example. I want you to zip this up by using 7-zip or whatever the zip archive program would be on Linux that you want to use. You can even use command line to do it. But really what I want you to do is zip this whole thing up and submit it, as well as a link to GitHub. Both are going to be used for this submission, so that's tomorrow's submission at midnight, as well as the next assignment 4. And why? I use them as backup. Guys, just in case your GitHub link is broken, as an example, or so on, right? I want to use that as backup because if you don't submit one or the other, then I have something, and then plus I also have your video, right, which is you explaining how things go. So that's really why I'm asking for it. It's not necessarily that I'm going to run your files locally. I'm going to use your video mostly. I'm going to use your video and take a look at what you've done here and what you've explained, and if you explain it properly, you're going to get your full marks. That's what I'm going to do. If I need to run your code, I will, right? Or if I have questions, as an example. But really, again, this is not a difficult thing to put together. All right, so questions around assignment 4. Sorry, can we download from repo and zip and then submit? Yeah, that's fine. Absolutely. That's a great idea, Tamina. Because at the end of the day, you know what? If you download it, it's already zipped for you, right? So there's nothing for you to do. It's a wonderful idea. Yeah. I didn't even think of that, to be honest. Right? That's the best idea ever. But that means that your GitHub repo works, right? So that's I can't make that assumption for everybody. All right. Anyone else have any questions around assignment 4 or assignment 3 that's due? Let's talk about assignment 3 that's due this Friday, coming up at midnight. Some questions I've already received for assignment 3, and we got some of them on our JavaScript course yesterday, were, hey, what about these, kind of the, let's go look at assignment 3 for a second. I'm just looking at assignment 3 now because I want to make sure that you guys are good. So part 1 for assignment 3, task 1, just to go over it again, is, hey, write a program, a console script, copyfile.py. That script will copy the contents of one file into another. Okay, this is pretty simple, right? That's pretty simple stuff with Python. But where people get messed up is this 2, number 2, and they say, well, we want to write a payroll.py program that reads the data.txt program, data.text, and the data.text program you're making this program, right, with 10 employee records, and they're only going to have employee number, last name, first name, and hours worked. And then I say something like, write payroll.py so that it reads data.text and outputs each employee record in a 3-column format like this, nicely, with a header row that includes the following information: hours worked. That's what it says. So my ask of you is, it says, one thing that it says here, and outputs the wages paid to each employee in tabular format. Well, this is, remember, I didn't make this thing. I just reformat it for you guys to make it nice and easy for you to read. There is no wages. I haven't mentioned wages. And someone smart enough said, wait, Tom, you said wages, but there's no wages. There's hours. How do we get wages? Make it up. is the answer I would say. I would say, like, put together a set of wages for each employee. Let's say, for example, wages would be an hourly rate. You could base it on hourly rate if you really want to. You can make it up. You can make it so it's an annual salary, and you want to break it down what it's going to be like for each week. You can calculate that simple. I leave it to you. It doesn't have to be dead accurate. For example, but I mean, you should think about minimum wage is $15 per hour, and if I have my hours worked as 40 hours, then if I want to calculate wages paid, which, by the way, there's no column for that in the output, I mean, you could. For me, I'm not going to look at that. What I'm going to look at is employee number, employee name, and hours worked, because that's what I've asked for. Okay? I'm not asking you to do any kind of calculations. Why is that? Because it's not asking you to do it there, and I'm not going to add additional things in here to complicate your lives. Why? Because guess what? You got lots of stuff going on right now with other courses, and I don't want to add additional scope to your assignment. Just do what I've asked you to do. Employee number, employee name, and hours worked. The rest, wages paid, yes, I put that there, but don't worry about it, because I haven't said it, right? What are the wages? Where are they from? If anything, they should be, if we were going to do this properly, it should be employee number, last name, first name, hours worked, and there should be an hourly rate. That's what's missing from this. And then if there was an hourly rate or an annual salary, one of those two things, then I would say employee number, employee name, hours worked as an example, and then, wages paid would be here. Okay? We don't have that. So I wanted to make sure that that everyone knew, because I know there was some confusion, and you know what? It's confusing. This assignment has been written in a confusing manner. I think another iteration of this course, if I was going to do it again, then I would change this assignment, or take it out or whatever. But if I was going to use the same assignment, I would add additional details. And thank you for that feedback, because that's something that was missed. Okay, so just do what the assignment says, and you'll get your marks. That's what's important to me. This format in a nicely formatted way on the console. Beautiful. Okay, so that is assignment 3 and 4. The only difference between assignment 3 and 4 is assignment 4 is worth 60 marks, and assignment 3 is worth 50 marks in terms of difficulty. I always add additional marks when I see more difficulty, and I've kind of put things in. I said, like, 20 marks functionality here. How am I going to get your 20 marks? Well, do you have the proper file names? Is it being read in, as an example, into... you don't have to use GetWords. GetWords is a recommendation from the author of this assignment, but you don't have to use GetWords. You can make whatever function you want to load or read from a file, right? And you can make, or if you want to use multiple functions, I would accept that as well. It doesn't have to be one function to rule them all, okay? I want your code to work. That's the most important. If you can make your code work in Python for assignment 4, I'm good to go, okay? Again, this has to be your own code. You need to understand it, just like I'm asking for assignment 3. So if you're taking stuff from the internet or whatever, you better know what it means. At the same time, there is a subsection here that I keep mentioning, which is external code. Make sure that it does not go more than 10% of your code. No more than 10%. So if you copy paste from someplace else other than the code archives that I've given you in my repo, I've given you some examples of code in my repo, then you're gonna, it's not good, guys. Don't cheat from each other. It's easy to catch. Don't try and just change variables. That's easy to catch. I can tell all those kinds of things. Please help me. Don't make my marking life difficult. It's already difficult, because I want to make everyone have the highest marks. And if you try and cheat, then that would be a bad thing. Okay, please don't do that for this one, and whatever you do, don't do it for assignment 3. Remember that these 2 assignments, each assignment's worth 15% of your grade, and 4 assignments is worth 60. I highly don't recommend you do anything like that, because that would be like really highly impactful of your GPA. Okay, I will catch you. It's just a matter of me looking through. If I see, look, think about it for me. If I have 30 students in a class and I get 30 submissions of the exact same assignment, it's just patterns, guys. I'm really good at patterns. I mean, that's part of like being a programmer, identifying patterns and refactoring. If I see your code and it's the exact same code as somebody else's, and with a few variable changes, I'm gonna know. All right. Also, here's something else that I really find interesting. People copy paste stuff that I haven't talked about from the internet, and they call it their own. Right? If I haven't talked about it, it's not in your slides. You better have a really good reason for using it. Right? Like, for example, some weird library or something. Unless it's an enhancement, like for example, the console looks awesome after you're done, right? Or something like that. Please don't use it, or get it approved from me first. Like say, hey Tom, look, I found this really cool library I want to use in my assignment. Is it okay to use? And if it's okay, I'll say, yeah, it's okay, right? And usually I do. I say it's okay. Sometimes I'll say no, because it might be too complex in my opinion, right? For you to use, or it might be too much code for you to include. But typically, I will say yes if you ask. And also you should cite the reference, so where you got it, what website you used, or whatever, if you're using code from somewhere else. Okay, that's just a standard practice, guys, and you should be like that across all your courses. If you're using some kind of code for JavaScript or C# or whatever, talk to your professors and make sure that it's okay to use that code. Say, hey, professor, is it okay to use W3 Schools for my JavaScript project? Whatever, for this particular piece of code. And if it's not, they'll tell you it's not, right? But typically, it's okay. All right, so I have another question from Sol. When I download the code from GitHub, it had folders that was in the path, such as workspace and documents. Would it be okay? Might be. It might be okay. Worst case scenario, it has to work with a relative path, so that if I use it on my system or your system, it shouldn't matter. Okay, that's how it should work. But don't worry, if I see it working on your video, right, that's the most important thing. Remember that the code archive on GitHub and the zip archive is literally a backup for your video. Your video is what I want to see. I want to see you doing the work in your video, in Linux, with Python, in Visual Studio. Okay, hopefully I made that clear, because I want to make sure you understand what you're doing. If you understand what you're doing, that's awesome. You're going to be, head and shoulders above other people if you can do that. Folder had Python files and text files. That's fine. So just like I said, it make it simple for me. If you can download it and make it run on your end, then that's fine on my end. All right, that's the most important part. Okay, so any other questions around assignment 3 or assignment 4? Again, I don't think assignment 4 is that difficult at all. I think you get a good code base to work from. If I asked you to do this from scratch, like on a test, that would be hard, right? That'd be like, okay, wait, what? What's a preposition? What's an adjective? People, especially non-native speakers, they'll be, wait, what is that? Hell, even native speakers might say something like, wait, I don't remember what a proposition is, or whatever, right? So I'm not going to do that. And then one of the questions I got on the chat was, why true, false, multiple choice maybe on, as opposed to a little assignment. I think you guys are in assignment hell right now, and the last week is going to be assignment double hell. I'm sorry to use that word, but there is no other way to say that. You guys are in deep trouble when it comes to the number of assignments you've got due the last week of class. And for me to give you an assignment that's due in 2 days, like I'm going to do for JavaScript, and another one for Python, and another one for C#, I just think it's too much. I think it's going to be enough. So there's going to be one of them out of the 3 that I'm teaching, right, that is going to be a true, false, multiple choice. And I'm going to make it Python because this is a new language for you guys. I want you to know the concepts of the language as opposed to necessarily how to do it. Your assignments are demonstrating that you know how to do the basics, which is what you're really learning here. You're learning the basics of Python in this course. And of course, I'm really hoping that when we get into the data science part, that you're learning a little bit more, right? Which is what we're doing today. Do you want us to put a docstring instead of a comment? Absolutely. I think docstrings are great for a header for your files, your classes, and so on. I think like this one. See, this is a docstring. I think a docstring is good. All right, if you want to use a docstring, which is multi-line comment, or if you want to use hashtags for your your comments, it's okay. But a docstring is more standard. Okay, that's the answer for that one. Anything else before we move on to today's lecture? All right, so yeah, let's get into this. So today we're going to be talking about arrays and how arrays are different from lists, right? An array is list-like, and we'll talk about how and a list is an array-like structure. But sometimes I want to look at arrays, especially with NumPy. Arrays to me are like matrices. Okay, I want you to take that back for a second, or take that in. When I hear an array in a NumPy array, it's like a matrix, right? Because a lot of times what we do with NumPy is we create a multi-dimensional array, typically. Okay. Then we're going to do, after we do some manipulation with something called ND arrays, all right, which are NumPy's arrays type. We're going to get into pandas, which is, again, like I said, data science. We use pandas a lot, and we're going to talk about what that is, and we're going to install it if we need to. We shouldn't need to at this point, because if I'm not wrong, I think matplotlib and Seaborn, and I asked you to put in scikit-learn and stuff like that. All those things include pandas, if I'm not wrong, or NumPy. So if it's not included, we'll know. If we try and do an import pandas and it doesn't come up, we'll know. So that's pandas gives you two different structures, and it's based on NumPy. So it gives you a series and a data frame. And a series is like a single dimensional array, and a data frame is a multi-dimensional array. You're going to see data frames are awesome, and we use data frames a lot for things like classification. If I want to make a chart-like structure, if I read from a CSV file, or if I make a chart-like structure that I want to create randomly, as an example, data frames make my data. And hint for assignment 4, using a data frame is pretty awesome in terms of output, right? Because what you can do with assignment 4, I'm thinking about assignment 3. Assignment 3, if you use a data frame, and I know I'm introducing it now, but the output from the data frame you're going to see is fantastic. It does row column format for you. So this is the one library that I would say, if you're going to use pandas for anything for assignment 3, I know assignment 3 is due tomorrow. If you could do that, that would be awesome for yourself, I'm saying, not just for me. If you don't, and if you're too far into programming already, then don't worry about it. Do what you're going to do. You can make console output on your own, customized output the way you like. So that's what we're going to be talking about today, arrays and data frames. Now you're going to say, wait, arrays, Tom, well, I know about arrays. I mean, I know about arrays in C#, I've done it in JavaScript, I've done it. Yeah, no. This is a different thing. Remember we talked about Python is a different beast. NumPy, really, it started back in 2006. What happened was there was a real need to make more performant array-like structures. Okay, because remember, data science really took off in the early 2000s, and it was around before, of course. And we're talking about big data. What ended up happening was that we had this need to create structures in Python, because Python, again, is being used by scientists, data scientists, and specifically to analyze a large body of information, large data sets. Okay, and they were using standard built-in structures, collections in Python, and the performance was slow. So what they did was they've created another C-influenced, I would say, library called NumPy, which basically creates a better structure for arrays. So it creates like an array-like data, and it's usually an ND array, which from now on we're going to call array for the remainder of this lesson. By the way, it says that according to libraries.io, over 450 Python libraries depend on NumPy. That's how popular this thing is, including things like Pandas, SciPy, Keras for deep learning. It's pretty awesome what NumPy has done, right? So of course we're going to import NumPy as MP. Let's see if it actually works, and it should work, because remember last time what we did. So we're going to just do some simple stuff with NumPy. So I'm going to make this new file. We're going to leave generator.py behind. Again, I'm inside of my Linux VM, and we're going to call this NumPy demo.py. Okay, just to give us some latitude, and we're going to import NumPy. Notice that it comes up right as MP. Okay, so that's our first statement, and just like it says here in NumPy documentation recommends this. Why? Because MP is a standard shortcut, if you will, that people use everywhere. When I first started learning Python back in the day, there wasn't as many of these, right? To be honest with you, but it's very Pythonic. I'll say it that way, to cut them down like this instead of a long word like numpy dot. I'd have to use NumPy for everything, right? As opposed to just using MP. And I'm not a fan of aliases like this. In general, I don't like cutting things down, but this is the Python way. And when in Rome, do as the Romans do, is what the common saying is, right? So here's what we want to do. We want to pass an array. We want to create an array, right? And the array is going to be 2, 3, 5, 7, and 11, right? So let's put that in together. So numbers is going to be the numbers array. So let's just do the simple example. So again, we're going to say numbers, right, is going to be equal to an mp.array, right? A numpy array or NumPy array. I'm just going to go back to this again. And notice the square brackets so that we're getting a list. We're creating we're passing in a list, and we're taking that list and converting it into an array. And you're going to wait, what? Why would I convert a list into an array? It's already a array-like. Yeah, but like we said, it's performance that we want, right? So we're going to say a list of 2, 3, 5, 7, and 11. Okay, so that's what's going to go in there. And if we print that out, again, we're not using IPython or anything like that. We're printing this out, and if I run this code, so Python, and then I say something like NumPy generator, NumPy demo, we can see that we get a list-like structure. But notice how we get extra spaces. We get this extra space here, and we get 3 spaces here, like 1, 2, 3. 1, 2, and then the third thing, 2 spaces here. Not sure you can see that, but what this is it's trying to format. Remember, one thing that NumPy does is it formats data here, and it's trying to format with the largest member. So 11, because it's 2 digits, and 2, 3, and 5, and 7 are single digits, it's going to format each of these things as if it's 2 digits. A good example of that is if I had a larger value in here, let's say I have a value like 100, right? And I ran this code again, then the output will change. It'll morph. So that'll give you the exact same spacing for everything that you get, including extra spaces before the number 2. Okay? So that's kind of something that is really good. So this NumPy, even if you use this for your output, a lot of times you get some really good output on the console. All right, so that's this. We can check the type. As an example, if I put the keyword type, and we know that it is a that type itself. So if I go type, so if I say something like up here, even if I do it here in the console, another good way of checking Python, remember we've talked about this, is actually doing Python in the console. So if I did the same thing, if I did import NumPy as NP, right? Again, as long as my console window is open, I can do the same commands. This is a good way of testing stuff out. So let's do this NumPy stuff, np.array. One thing you're not going to get on the console is any kind of code hinting, right? Which is, to me, important, right? So sure, we'll put 199 instead, just to make it different, because my typing issue. And if I say something like, if I want to get the type of numbers, and I press enter, you're going to see that the class is of type numpy.ndArray, right? That's the type. So you can do that right here. Anything that you show, that I'm showing here inside of, if I want to get the type. The other way to do that, of course, would be to wrap a print statement around this. So if I was to go back to here, instead of numbers, I wanted to get the type, I can literally wrap a print statement around type. Now I'm going to get code hinting and code coloring. There's my code coloring. And then when I do that, I can say exit from here. And you can see clearly that it's going to do the same thing. Class numpy.ndArray by wrapping a print around an output like type. Okay. That means that I can do an if statement. If I know that I can output type, then I can compare type too. Or I can say if the type is of type ndArray, we're good to go, right? If it's something else, then maybe something's wrong. You can do type checking this way. Okay, so that's good. I'm just going to go on, move on here. So we talked about commas and spaces and how it outputs stuff accordingly. Multidimensional arguments, it's pretty awesome. If here I'm taking a list of lists, right? And when I output the array, if I want to output this particular object here, right, then you're going to see that it reformats the list of lists to look more like a matrix, right? And again, for those people who don't remember matrices somehow, it's not that terrible. Again, if you look at, let's go back to, so I'm going to go back to here for a second. So again, 1, 2, 3, 4, 5, 6, that's, again, you see that there are multi-dimensional array. So this is square brackets around the outside, mean it's a list. And we're going to have a list of lists. So a list that includes an inner list, and the first element is 1, 2, 3, and the second element is 4, 5, 6. Okay, so that's a list of lists, multi-dimensional array. Let's do that. So again, if I said, we'll call this thing, actually we'll go on. And if we said something like, we'll call it multi, right? And we'll say mp.array. So mp.array is basically an initializer that creates the thing. So we're going to say it's a list, right, of lists, 1, 2, 3. And then the second element is 4, 5, 6. Another list of 4, 5, 6, right? So there's this one, which is interesting. And then if I say, if I want to print multi, if I can type properly, which I can never do, then you can see it does exactly that. It kind of formats it, but it puts it in this format, right? If instead, if I had a multi was not an MP array, and if it was something else, let's say for example I had, you know, let's call it matrix, right? If matrix was this, so this thing here, right? So let's do that multi-dimensional array again. Okay, this is this, and I want to replace this part in here with the matrix, right? This should still work, but I also want to print out what matrix is here. Okay, so I'm going to print out matrix. And again, we're just doing some manipulation here just to show you the difference. Take a look. So, yes, this is an ND array. I'm just going to get rid of this thing. We don't need to see this anymore. Matrix is 1, 2, 3, 4, 5, 6. I print matrix, it just looks like this. 1, 2, 3, 4, 5, 6. Just the way it came in is the way it comes out. Whereas the formatting for the ND array that we create with NumPy creates this. 1, 2, 3, 4, 5, 6. It looks like a matrix. It takes away the commas altogether, and it puts it simply like this. It's a great way of visualizing what this is. So if you were to look at this as a matrix, let's make the matrix a little larger, a three-dimensional matrix, right? 7, 8, 9, right? If we were going to use a three-dimensional matrix like this, right? Here's a three-dimensional, or sorry, it's a two-dimensional matrix, right? A two-dimensional array, in the array, but it's a matrix that's a 3 by 3 matrix. That's what I mean, a 3 by 3. So if this is a 3 by 3 matrix, right? These are the columns, right? And these are the rows. And we're going to see if this is still true when we look at NumPy and how NumPy interprets this. Okay, so again, 1, 4, and 7, that's a column. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, those are the rows, right? The way we have it here. Okay? Rows and column. Let's continue. So they have something called array attributes, right? And here's an example of if I want to create a group of integers, right? I can just assign integers 1, 2, 3, 4, 5, 6, right? And these are just integers. If I assign floats, for example, 0.0, 0.1, 0.2, 0.3, 0.4, notice that the 0.0, any trailing zeros are removed from NumPy. And there's a reason for this. Some of it's formatting. And also because it's not significant. That's how it looks at it. Again, remember, this is generally for data science. This has been done. So the trailing zero is not significant, so it's been removed in the output. You can also look at something called, you can use the dtype attribute. That's a built-in, right? And I want to see what the data type is, as an example, for integers, in this case, or floats. So what is the data type for us? So if I go back to our example, what is the data type for multi? So if I say print multi.dtype, right? Now remember that one thing that I always crave is that it'd be nice if we had a code hinting for some methods like this, which we don't, unfortunately, here. So that's one thing that I miss with VS Code. In other languages, we do get code hinting. I mean, I can hover over a lot of times and get some kind of code hinting. I'm not getting any of that here whatsoever. Let's see what that does for us, though. If I kind of do this, it says int64. Try that again. Int64 is the data type for this integer 64. It's a 64-bit integer that we're getting for the data type for this particular array. Okay. Again, to me, when I see this, it looks like a matrix. If I wanted to make this a 4 by 4 matrix, then I would literally just put, let's say, another value. 4 by 4 matrix would look something like this. 4, 5, 6. Wow. It's been a long day. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. If I did this for the matrix, you're going to see how it outputs it, right? This is a 4 by 3, right? And let's do another one. One more. So 13, 14, 15, 16. Right? There we go. 4 by 4 matrix. So it looks like that, right? 1, 2, 3, 4, 5, 6, 7, 8 rows and columns. And also notice how it nicely formats the output so that it's not all bunched together. I didn't have to do any of that work. If I try to do this with some kind of for loop, that would be a problem. So that's another reason why we use NumPy. We use NumPy because it formats things beautifully for us in the output, right? As opposed to us having to do this manually ourselves, add spaces and so on. Look, there was a need for this, a big need for this a lot of times, right? And so, we just made, Python do it all the time as opposed to you doing it from scratch. It's almost like it's a common function to output stuff. Let's just make it so that it's part of the structure, which makes sense to me. All right, so that is, you can look at the types if you need to. The other thing that we can use is the ndim attribute of the array. Ndim basically shows us the number of dimensions. So let's try that. Ndim. So I want to find the number of dimensions. Why would I need this if I know that I'm making my array myself? Well, because sometimes, remember, we're analyzing data that comes from a data source or some kind of data set, and we want to get the information. So this is interesting. It says the number of dimensions is 2, but meanwhile we have, it's a 4x4 matrix. Why? It's a two-dimensional array. Two-dimensional array, right? An array of arrays. If it was a 3-dimensional array, it'd be an array of arrays of arrays, right? That's not the case here. And whenever I think about a 3-dimensional array, I always think about a cube, right? Some kind of cube of data. And, believe it or not, we use 3-dimensional arrays for things like color variance in graphics. If I want to use a lookup table to change the color variance, if I want to make a scene in a video game look like it's cooler or look like it's warmer, like brighter or darker, and a good example of that is if in a video game, as a good example, we have a scene and we want to make it look like it's daytime. And so what I can do is I can colorize the entire scene by adding another post-processing effect where I use a 3-dimensional cube, right, of color layers, if you will. And I can pick from that cube, 3-dimensional cube, which of the colors that I'm going to use for which of the pixels that are on the screen. Interesting. But that's what we'd use a 3-dimensional array for a lot of times. Also, sometimes what we have is a 4-dimensional array. Whenever I look at a 4-dimensional array, I always think about a 3-dimensional array over time. What would the cube, what would something be in 3 dimensions over time? 4-dimensional and 3-dimensional arrays are also used for coordinates, right? If I use a 3-dimensional array, I might want to know the coordinate system that's for example inside of a 3-dimensional space. Like for example in VR, I want to know exactly where a particular object is in VR. I use the 3-dimensional array for that, right? Or in this case, an X, Y, and Z coordinate. But yeah, you can do all kinds of stuff with matrices and arrays. But here, even though we have a 4x4, what looks to us as a 4x4 matrix, we really only have 2 dimensions. Okay, so it's just something to note. And we can also look at something called shape, right? And what is the shape, right? And shape basically says how many rows and how many columns. Okay, let's take a look at that. That's actually pertinent for us. It makes sense, right? So if I said something like, I want to also print the shape of my array, what does that look like? It looks like this, a 4x4 matrix, right? If I was to take one of these things out, so if I took this part completely out, let's say I didn't have this part, right? And it was only this shape. And if I did it again, you'd see that we have 3x4, a 3x4. So how does that make sense? 3 rows by 4 columns. But that makes sense. You can see that here. Like the first column, second column, third column, fourth column. Here it is, 3x4, right? A 3x4 matrix as opposed to a 4x4. So really what this is showing us is it's row first syntax. Row, column. And why does this make sense, row, column? Because if I think about rows as the x coordinate and columns as the y coordinate, this totally makes sense. This is like x, y format, right? X and y format, right? So if I want to look at, row 0, column 1, row 0, column 1, that would be the number 2, right? 0, 1. And that's how you would look at that when I'm making some kind of grid this way, okay, in this 2-dimensional example. So that's what this is. That's what the shape does. And shape is really cool because what it allows me to do is we can reshape it later. If I want to reshape it and change the shape into something else, we can do that. And there's functionality for that we're going to see. Okay, let's undo that change. I want to get my 4x4 matrix back. Again, if I go back to this, you can see now it's 4x4. Okay. Cool. I can also get the size. So again, what size does is the number of bytes required to store each element, right? Sorry. Total number of elements is size. Total number of the byte size to store each element is item size. I'm not going to get into that. So size is important. How big? If I want to iterate through my multi-dimensional array, I would do a nested for loop like we've seen before, right? So again, for every row, and then for every column in the row. So notice that's a little different. For row in my particular matrix, right? And for every column in my matrix, how would I do it? I'd print it out like this. Let's try that. So kind of a nested loop for us to do that. But it's interesting how the Pythonic way, how it's done in a Pythonic way, right? So, and what I mean by that is I'm just going to comment this stuff out so we don't have to see it anymore. Because we've already done these examples. So I want to do a for loop. So for every row in my multi-dimensional array, right? Then what I want to do is I want to say for every column in my row, then what I want it to do is I want to print something, right? And if you notice what it does, what it prints is you're going to print the column, and then you're going to end with this space, right? A big space, right? So let's think about what that looks like. If I didn't put the ends with, so if I want to print the column, and if I don't put any spaces in there, what happens? How does this thing run? Does this, right? 1, 2, 3, 4, 5. It just iterates through, right? And remember what printing does by itself. Every time we print, we add a new line character by default. So if I said just change this to end is equal to nothing, like this, and I was going to do it again, and you can see that it just does everything in one line. 1, 2, 3, 4, 5, 6, right? If I add additional spaces like this, right, then it does this. 1, 2, 3, 4, 5, 6, all the way to 16, right? Which is kind of what we have here. But notice that I can add in more spaces, and somehow we get this output, right? Which we're not going to see, right? And notice it says we're printing, and then on the outside we print again. So this is where we get that extra output. So if I was to do that, let's go back and do this. There's the extra print statement. So this extra print statement happens at this level, at the four columns level, this level here. We can do an extra print statement in here, which actually formats everything as required, right? You can see now we get this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on up to 16. If I want to add more additional spaces, let's say for example we know that I want to add an extra space, right? See, it's better. Let's see how NumPy prevents all this stuff, right? Like I don't need to do any of this typically if I want to iterate, right? It's almost perfect. You can add another space, and this is what they did here in the example, is they've iterated through to create a formatted column row syntax until you get closer and closer to the number of columns and rows that you need. Okay, it's not going to be perfect. Look at that. It's like looks like crapiola, to be honest, right? And so you'd have to do something else in here to make this better, because it's going to give you output like this. Again, depending on how many of these you add in. If I add another one and another one and another one, it's going to give you, spaces that are wider and wider until you get something that's closer to things aligning. Look at that. Right? You're not getting much better there. Right, so it looks like between one and the other they're exactly the same. Let me see that. Sorry, I didn't save. better. It's like these are aligned now, but not the rest. So you'd have to add more and more spaces because you're trying to align for the number of of columns and everything else you've got in there, right? So that almost looks identical, does it? 3, 7, 11, 15, 4, 8, 12. No, it's closer. I think that's it. I think that's the most you can get. See? Just pushes things out more. Right, so you can see how ugly that looks. That's not looking pretty good. And how can we remedy this? Right, well, we can print things out differently. We can add additional spaces and tabs on our own, right, by using an F string as opposed to the way we're doing it here. Okay, so not the greatest example, but using an F string would help us a lot. All right, this one worked because again we only have 2 rows, right, by 3 columns, a 2 by 3 matrix. That's what this looks like. And then what you can do is if you wanted to, you can print everything flat. So if I wanted to iterate through and the entire thing, I can use the flat attribute to do all that. So instead of doing all this, I don't have to do multidimensional or nested for loops at all. I can say multi.flat, and then I can just print our row for each of our rows. This is really number more than row. If I was to do this and try this out, you can see now that I get everything in a flat order. If I add in, of course, the end, right, equals to kind of a space, then we're going to get the same thing that we got before by using a multi-dimensional array. Okay, so that's kind of the way to use flat. That's part of the structure here. I know it's like super exciting at this point, but we're looking what NumPy can do for us, right? Which is what we're doing. I'm going to skip through some of this. I'm not going to demo everything. Zeros. This is interesting. It has NumPy comes with something called zeros, ones, and full, where zeros fills an array with zeros, as an example, and we can ask for how many we want in there. So if I want an MP, I want to kind of inject 5 zeros inside of an array. I can do that. I can create this returns an array of zeros. So 1, 2, 3, 4, 5 zeros. Notice it gives me an array of 0 floating point numbers, right? Ones, the same thing. Ones will fill up an array with a number of ones that I want. How many ones do I want? Why is zeros and ones important? Because sometimes I want to initialize an array with ones, or a matrix with ones or zeros, and if I do that, I can multiply that matrix or this array by another array and get certain results, right? Here's an example of ones. You can also use the dtype attribute or option, and the dtype option specifies whether you want to make it integer or float. By default, it's float. So you can see that here I'm injecting ones, and you can also use full. And what full does, I want to fill it up. I kind of create a 4 by 4 matrix, let's say, or a 3 by 5. So here's a 3 by 5, 3 rows by 5 columns, right? And I want to fill it with 13s, as an example. Now this filler, whatever I say here, could be a calculated value. You could do that, right? Instead of just making it a value, as long as I get an integer in there or whatever I want, it's going to fill it with the value that I tell it to. So that's kind of an interesting way of filling up a matrix or an array with data, right? One thing we use a lot is something called arange, which is similar to using range but more performant. Okay, let's talk about this. I want to make an array of a range, an array range, that's what it is, a range of 5. So it'll just put in things from 0 to 4, right? And so the things that I did manually, as an example, where I said I want to go, 1, 2, 3, 4, and fill in the blanks here, you can use arange for that to do your work for you, right? The other thing you can do with arange is you can add a modifier at the end. So you can say arange, I want to count from 10 to 1 in -2 steps. So go 10, 8, 6, 4, 2 as an example, not including the last. We never include the last value. So from 5, if I just put a range of 5, it's 0, 1, 2, 3, 4. where we assume 0 is the minimum and 5 is the maximum, not including 5, right? If I put a range 5 to 10, it goes 5, 6, 7, 8, 9, not including 10. Here it's the same thing. I start at from 10 to down to 1, not including 1, right? So it goes by steps of -2. That's how that works. So let's think about how to rewrite our code to use a range for this. Okay. So right now we've written our matrix like this, right? And what I want to do is I want to create a matrix, right, or an array, an MP array of arrays. So let's see how we can do that without doing it the way we're doing it. Okay, so let's get rid of numbers because we don't need that for now, right? And we want to redo our matrix. I want to kind of do row 1, row 2, row 3, row 4. Now let's try this first. So say row 1. If we did this like this, row 1 is equal to, we want to make an MP A range, right? It's going to return, remember what we're returning here. So the first one is going to be from 1 to 5, right? And then row 2, think about this. How can we make this better? MP.arange, and we're going to go from 5 to 9. And row 3, we're going to say MP.arange, and we're going to go from 9 to 13. And finally, row 4, we're going to go from an MP arange from 13 to 17. Okay, and remember I'm going up to, but not including. So I've got these four ND arrays now. 4, 1, 2, 3, 4. And I want to put it together into a matrix. So can I do something like our matrix, right, is just, I want to have each of the rows in there. What can I do with each of these things? Well, we're going to come back to that. Let's print out row 1 as an example. Let's think about this for a second. Here's row 1. And what is it going to give us? This is before we do our matrix down here. So again, it gives us 1, 2, 3, 4, right? Because it's a single dimensional array. A single dimensional array. So what if I want an array, if I said matrix 2, right? If I want to make it so that it's an array of row 1, row 2, row 3, and row 4. Am I going to get an error if I print out matrix 2? Print matrix 2. You're going to get this. It's a weird thing, right? I'm printing it out, but I'm not really getting, I'm getting an array of, it says a list of arrays. Okay, cool. What if I did it the other way around? So I want to say that, okay, this is cool, right? Remember that this is, I want to make it an array, an MP array. So I can do the same thing, matrix, I can go MP.array, and I can wrap MP array around this stuff, right? And now what do I get? Exactly what I got before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 16. So this is another way of doing this, but wouldn't it be nice if I can iterate and create this structure and somehow add it in to my array? How would I do this with a for loop, right? One of the things to note is that I'm creating these little ND arrays inside. So I've got an array, an ND array of ND arrays. You know, it's like, but it creates an ND array at the end. So if I was going to say, okay, what is matrix 2 data type? Right, so if I said D type, what is that? Just like I've done here, I said, what is the data type of matrix 2, right? Int64 is what it tells me. It doesn't care. The data that's inside the object is what we're looking at, right? So it's kind of interesting, again, the way this works. Okay, so you can do it this way, right? An MP arange creates that structure for us, right? But again, how would I do this in a looping way? I want to loop through and I want to say that I want to somehow add in, all right, or connect with these different kinds of ND arrays, and I want to create an MP array of ND arrays, right? So I'm going to create it first, right, somehow, right? And then after I have them, right, I want to create something like this. Well, remember, we did a list of these things. A list of ND arrays is what we did here. A list of ND arrays. Then we made it into this, right? So if we calculated this thing and we said that, well, instead of using row 1, row 2, row 3, row 4, which is very wasteful, right? If we did a for loop instead, so let's say, for example, I said I want to have matrix 2, right? Is what we want. Matrix 2 is going to be a list. Okay, let's just say. So it starts off as a list. Even if I did this, starts off as a list, and then I converted it into this. Let's try this. Does this work? Yeah, it does. I mean, let's go back to printing it out. So even though it starts off as a list, this is the way I would construct it, right? It starts off as a list, but it doesn't matter. At the end, it becomes we can redefine it as something else, right? Okay. So if this is true, right, then couldn't we say that I want to add to this list? How do I add to list? Does anyone remember how to do that? Right? Does anyone remember how to do? I want to make a for loop. Here's my challenge for you guys. Put this up on GitHub in a second. And I want to say for for row in range, we can do a range, right? For row in range from 0 to 5, right? Not including 5. So a 4x4 matrix again. So range 5. I want to do matrix 2. I want to do some kind of operations to matrix 2. And what I can do, I can append, right? I can append something to matrix 2. I can remove. I can add elements to matrix 2, right? There's a bunch of stuff I can do. I can clear, copy, count. These are all things I can do, but I want to do an append. So I want to append to matrix 2 this object, whatever the object is going to be, which is an mp.arange, right? And I want to go from 1 to 5 every single time. And I'm just going to comment these things out for a second. Okay. And instead of doing my MP array of row 1, 2, 3, 4, we're not going to have row 1, 2, 3, 4 anymore. We're going to just have matrix 2. Can I not do this? Now, it's not going to give me the result I want yet. Okay, we're going to figure this out in a second. Here's matrix 2. Then what would that look like? It gives me 1, 2, 3, 4, 1, 2, 3, 4 every single time, right? So that's kind of part of it. I want to loop through, and when I get to the end, after my range is done, as an example, I want to do the next column, right? So depending on what my column is, right, I want to add, how do I go 5, 6, 7, 8? I want to keep counting. So I want to go row in range 5, right? So I'm going to keep counting in range 5. And when I go to, when I'm done, right, what I want to do is I want to do it again. And I want to do this 4 times, right? So this is like, when I do this, 1, 2, 3, 4, I'm going to do this 5 times. I'm going to do like 5 columns, right? So every single time I go in there, into this range, it's like I want to put in this row column format, or column, row column format. So I want to go from 1 to 4, and then I want to do something else. What if I did that? What if I kind of did a for loop like this? So for column and row, right? I want to do column and row, and what I want to do is, depending on my MP range, it's going to be based on the row information and the column information combined somehow, right? So for row, it's going to start off at 0, 0, 1, 2, 3, 4, 0. For row 0, I want to multiply my row, right, by my column information. So my column is going to be 1, 2, 3, 4, right? So that's going to be in range 1 to 5. This is my column information multiplied by my row. multiplied by my row. Well, if that's the case, then if I get to column 2, does that make sense? Or maybe I would add it to my row, right? So if my row was, 5, 6, 7, 8, 9, 5, 6, 7, 8, then I would add 1. And does that make sense? So row, again, it's from in range 5, column and row. What do I get if I just do this? So column and row, I want to do for every column, what do I get when I get this? I get a traceback because what's happening is I'm saying, okay, for every column and row, I want to keep appending a column to the matrix, right? So I'm going 5 rows deep, 0, 1, 2, 3, 4, and then for every column, I want to go range, instead of doing this way, I want to do a range, again, of 1 to 5. Let's say if I did this, for every column in range of 1 to 5, how would I do that? When I append, I'm appending these things over and over again. My problem is not that I can't do this. My problem is down in here with my NP array. Right? It says that int object is not iterable, column and row. All right, so that's what I try to do up here. Let's try that again. All right, so we get this massive array now, like really big, right? Because I get like all of this. I kind of did what I wanted, but it's like for every, it's not exactly 4 by 4. How would I do this differently? How would I do this differently, guys? How would I make it so that it's 4 by 4 if I want to loop through? Remember, I'm already kind of looping this way. This is kind of doing the loop thing, right? 1, 2, 3, 4. I just want to add to it, right? So let's back up. So I want to do for column and row, right? But I kind of don't want this to happen. I don't want to do too much complications here. So I'm just going to go back out. And let's make sure we back out to this. So this does what I want, but it does 1 to 5 every single time, right? Is there something I can have? For example, some kind of counter. So if I say my count is 0, and we can call this the row count, or column count, or whatever you want to call it. Column multiplier, or whatever, column multiplier. We'll call it column count. Well, column count starts off at 0, right? And what I want is every iteration, column count's going to go up by an amount. By what? By 4. So we'll say column count, right, plus equals to 4. Okay, so we're going to add 4 to it. So from 0, it's going to go to 4. From 4, it's going to go to 8. From 8, it's going to go to 16. All right, as an example, every single time. And here what I want to do is I want to add column count to it. I'm going to say plus column count, right? So 1 plus column count, that means that if I add, for the first iteration, it starts off at 0. Then I add 4 to it, right? And it's from column count plus this, plus column count here too, because I got to add that too, column count. All right, so I'm going to add column count twice. 1 here and 1 there. Let's see what that does for us when we did this. Does that solve our problem? Yes and no. It does 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it kind of does a little bit of an extra iteration, which I don't want. Let's reduce this number to 4, which actually does what we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have a way of iterating without doing all of this insanity. Right? We don't want this to be done in any way. And I'm sorry, but my selection still doesn't work for some reason. I don't care. I'll make do. So matrix 2, you can do this matrix instead of doing it the way we did it. We can have a matrix, right? We can have a matrix do exactly like what we want it to do. You can do it long ways like this, or you can do it like this. It doesn't matter. NumPy doesn't care, right? It'll do what you tell it to do. Okay. All right, that's a little bit of an example that I want to share with you. Let's put this up on GitHub so you guys can do the same thing if you need to. So I'll say git add dot git commit -m, and I'll say first example. That's really our first example. Git push, and that'll push it up to GitHub. So you guys have all that. Wonderful. Let's go back to the PowerPoint and zip through it because we have a lot more to cover. So that is the A range. It kind of does ranges. This is important for generating numbers between a certain certain values, right? Linspace. Okay, this is what this is. It gives you starting and ending values, right? As an example, so we say I want from 0.0 to 1.0, and I want a number of equally spaced values between all these things. For example, I want a number between 0 and 1, but I also want 5 total values, including 0 and 1. So what this does for me is it creates all the spaces in between numbers, right, between 0 and 1. Okay, that's how it goes. So 0, 0.25, 0.5, 0.75, and 1 are all equally spaced. They're 0.25 apart. That's what linspace does. Okay. Reshaping is really, really important. Okay. So an example would be if I want an array, and this is kind of what we did earlier. I want an array between 1 and 21, but I want to shape it into a 4x5 matrix, right? 4 rows, 5 columns. Oh man, we could have totally done it this way without doing my crazy iterations, right? Yes, we can. That's what reshape does for us. And let me show you that. So here's reshape. So let's suppose I have a matrix 3, and matrix 3 is going to be an mp.array that I'm going to go, I want an array that goes from a range of, just like it says here, and notice this is something called chaining. I want to generate an array or an ND array between range 1 to 16, right? But I want to reshape it to a 4x4 matrix. That's what I want to do. So again, mp.arange from 1 to 16, but then I want to reshape it to a 4x4 matrix, right? And if I did this, and if I said print matrix 3 as the end, then you're going to see that I'm going to get an error. Try that again. And take a look at that error that I'm getting. It says value error, cannot reshape an array of size 15 into a shape of 4x4. Why? Well, because of the way I specified, right? I specified an array or a range of 1 to 16, but not including 16, right? There's 16 elements now, and now it should work. And it's exactly the same thing we had before, but we have this little for loop. Let's just comment out this little for loop so I don't mess things up, because you already have this information. Let's try that again. We're going to see that array happen twice. Right? So it's exactly the same result, the first one and the second one. Here, up here, I really worked hard to try and figure this out. Here, down here, I didn't work hard at all. That's how NumPy works. NumPy works to make your life easier. And the way it does this is it has to have an even amount for you to make a 4x4 matrix. It calculates it and says, can I do it? Can I take 16 values and divide them equally in a 4x4 matrix? Is that possible? So if we calculate this again, then let's take matrix 4. If we say matrix 4 is equal to np.arange, can I make a 3x5 matrix? You know, a 3x5 matrix is 3 rows by 5 columns. 3 rows by 5 columns. How many values do I have? I have 15 values. That means I got to go from 1 to 16. So I would do 1 to 16. I have 15 values, right? And I want to reshape it into a 3x5. All right, and then I want to print if I can type in print matrix 4. Okay. And there it is, 3 by 5 matrix. It'll do whatever you want as long as there's enough data. In this case, there's enough data. There's 15 values, and we're going to put these values in the 3 by 5 matrix nice and easily. Okay. Reshape. Reshape is one of the most commonly used NumPy functions. Why? Because we can take actual data, let's say X number of values, and reshape it into the shape we need, right? Which is good. Okay, let's get back to this. So that's what reshape does. It talks about how to do that in good order. Sometimes we have a large array, and how it displays large arrays is interesting. If I say I want an array in a range of 1 to 10,000, so 10,000 numbers, right? And I want to reshape it into 4 rows by 25,000 numbers, 25,000 columns, right? What it will do is it'll put ... this notation, an ellipses notation between the third and the last 3. The first 3 and the last 3 columns, it'll only display this much in this default state. And it'll give you this range. So it'll basically show, hey, I've got values between this and this. It'll calculate everything for you nicely and put everything in the correct places, but it won't show every single column because it knows, that's why that NumPy is awesome, that you can't possibly print all this stuff out to the console. And it's the same thing when you have, I have a number from 1 to 10,000 again, and I want to reshape it 100 rows by 1,000 columns. Like, it's massive what it's doing here, right? So it's going to create a 2-dimensional array, but it's going to be a large matrix of data, right? But think about what this matrix of data is. It's like an Excel spreadsheet, right? Where each of the columns might have a header in this case filled with data. So now it does it twice. It does it the ellipses here, colon, as well as between these 3 and the bottom 3, ... So this, when it prints out like this, indicates that it's a very, very large data set. We have array operators that we can use. I was trying to do, now they can create, we can add 2 things or multiply 2 things of the same shape. Again, this reminds me a lot of matrices. And you can also use something that looks like this. I already have an array, right? And what I want to do is I want to multiply that particular array by 2. Then all the elements in the array are multiplied by 2 each. It's an element-wise arithmetic that happens, element-wise. So it goes like 2, 4, 6, 8, 10. If I cube it, remember like star here in this example is cubing, then it becomes cubic values at the end, right? So I can cube the values at the end. So 1 times 1 times 1, 2 times 2 times 2, and so on, right? And that's how it kind of works. Okay, one thing to note is if you do any of these arithmetic kind of operations, it does not change the original array. What it does is it returns a new array, which is a really important concept because it doesn't do anything to the original array. An array, in this case, is kind of immutable. It returns stuff and into a new array. Okay. However, we can also use an augment. An augment assignment, what it does is I can take each of the array elements and add 10 to them. That's, again, it is an element-wise operation, and then in this case it does modify the numbers array, right? So if I did some kind of augment, an augment means like plus equals or minus equals or divide equals or star equals, as an example. It'll modify the original values. Okay, so that's what some arithmetic you can do with NumPy. There's also a concept called broadcasting. So remember, we have a matrix, and we can multiply it by a scalar, okay, in mathematics, right? So if I want to multiply, for example, the numbers array by my own array, another array. So here's an example of, I have my numbers array. My numbers array is in the correct shape. Remember, you can only multiply these together if it makes sense. So here is what I can do. I can say take this numbers multiplied by 2, 2, 2, 2, like this, right? And what this does is it allows me to create, and then they have to be in the same shape. But what you can do in other words is do the same kind of idea. You can say that I want to take a linear space. That's what lin space means. Between 1.1 and 5.5, I want to create a linear space, a linear array, if you will, right? With 5 values. So 1.1, 2.2, 3.3, 4.4, and 5.5, because it gives ranges from 1.1 to 5.5 inclusively, right? And there's 5 of them, 5 equally spaced numbers. That's what this does. If I multiply numbers by numbers 2, and numbers over here is we calculated earlier, which was 11, 12, 13, 14, 15. It's the same shape, 1, 2, 3, 4, 5 elements in a single row. So 5 columns in a 1 element. It's a 1 by 5 matrix. That's what it is, a 1 by 5 matrix, right? If I take a 1 by 5 matrix and I multiply it by a 1 by 5 matrix, which is what this is, so you can totally do that. They're the same shape, right? Then I can get the result. That's what broadcasting does. We can compare arrays. We can look at 2 different arrays, and here's the numbers array, 11, 12, 13, 14, 15, and I can say is numbers greater than or equal to 13. What it does is it produces another array that injects trues and falses if the condition passes. So for example, is 11 greater than or equal to 13? No, false. Is 12 greater than or equal to 13? No, false. But these are, right? So it goes false, false, true, 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 and it creates another array for this. This is great when it comes to you want to analyze a data set, as an example, and I have tons of data and I want to compare. I only want to return those values that pass a particular test. For example, a comparison test like this, greater than 13 or less than a certain value. And I can identify which ones. So that's comparison, and I just want to skip down to calculation methods. Okay, so one thing is, if I had, here's an example of an array of grades. So I have a matrix, again, let's think about this, how we would talk about this. 4 rows by 3 columns. So we would say it's a 4 by 3 matrix. 4 rows, 3 columns. We're using column-wise addressing in this way, right? So, sorry, row-wise, row, column. So this is, like I said, a 4 by 3 matrix. This 4 by 3 matrix, once we have this data, what you can do is you can use a calculation. And this is where it's really awesome, where NumPy has built-in functions like sum, min, max, mean, standard, and variance. Standard deviation is what this is. It allows you to do the mean for the entire matrix, which is awesome, right? So, or you want to sum up a certain thing. So let's say, for example, I want to sum up everything that's inside of my array. I can use the sum calculation. I can say that, okay, I want to print the matrix.sum. I want to sum that up, right? What's the sum of my matrix? Then I can do that matrix. How about, there is no matrix. Sorry, I'm using it as a thing, but actually it's this. Unexpected end of file. What did I get here? Oh, I didn't add a closing bracket here. Let's do this again. List has no attribute sum. Sorry, what did I? Oh, that's a matrix. Matrix 4 is what I want to do, not matrix. Matrix. And that makes sense now, because that's why I wasn't doing this thing that I wanted to in the first place. Errors. Yay, 120. So it kind of counts up all these values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and gives me 120. If I want the mean, what is the mean value of this, like an average? It does 8. 8.0 is the mean of all these things, right? And if I want the standard deviation or something else, I can calculate it there. And it does these because these are built-in functions that are built into NumPy. Min, max, find the maximum value, the minimum value of a matrix, whatever I want. I call it a matrix. I know you're thinking, like, why is he calling it a matrix? Because that's what it is, if you think about it, right? It's a matrix. It's a multi-dimensional array. Multi-dimensional array in my mind, that 2 dimensions, is a matrix, as long as each of the dimensions are they're equal, like the way we've made them. You can calculate by row and column by putting in, let's say I want the mean axis 0, again, is as an example, is by I believe it's by row, right? Because the first thing, row, column. So axis 0 is by row. And then if you want column calculations, right, as an example, you can do column calculations by specifying axis 1. So let's do that. So if I want the mean of my axis 0, then I can do that. So again, going back to this, I want the mean where axis is equal to 0. And if I did this, then you can see clearly that I'm going to get 6, 7, 8, 9, and 10. And I'm getting an array back, right, of the values, right? Now, how did it calculate this? Look, it's each column that I'm getting back. So axis 0, so it's row-wise calculations, right? So I'm saying for each column, 1, 6, and 11. If I take 7 and 11, 7 and 11 becomes 18, and I divide that by 3, I get 6, right? 2, 7, and 12. 9 and 12 is 21, divided by 3 is 7. So I'm getting these values. So it's axis. If I do it the other way around, by axis 1, it's the opposite, right? So, and I know I'm timing out. We'll continue the next week. Don't worry. 1, 2, 3, 4, 5, right? What's the average now for these? Notice there's only 3. So I'm doing row-wise, right? Or column-wise count, but row-wise calculations. So 1, 2, 3, and 3 is 6, and 4 is 10, and 5 is 15. Divide that by 5 is 3. And that's how you get these numbers, right? So it's doing the mean or the average for each calculation that you want. So pretty cool. And all built into to NumPy, right? Which is kind of cool. A couple more minutes, guys. So that is this. There's also a lot of universal functions that it has built in. For example, you can use things like square root. I want to get the square root of all the numbers that I've got. So let's say I make I have a ND array of numbers between 1 and 36 as an example, and I want to get the square root of each of the numbers, and I return a new array. Then those are all the values. I can do a square root operation on an element-wise operation. And there's a lot of other really cool universal functions that it comes with. All right, not just square root, but there's add. I want to add 2. Now they have to be similar. So in other words, like the same kind of size. I want to add 2 different kinds of arrays together. You can see that I'm doing that. 1 to 7 times 10, which means 10, 20, 30, 40, 50, 60. That's what they are. That's what this is. And then I want to add numbers and numbers too. Numbers, remember up in the above was 11, 22, 33, 44, 55, and so on. You can add them together to produce a result. All right, so that's kind of how that works. And there's a bunch of other ones. Here are all the different universal functions that come in with NumPy. For example, things like subtract, multiply, divide, sine, cosine, and tangent, different kinds of comparison operators, floating point operators, floor and ceiling, and everything else. And the little dog too. It's got everything in here that you can possibly ever want. If we had 2 days to do everything, and this is how I normally break it down, I would talk about intro to data science. And as you saw, the first 40 slides took all of my time, as well as talking about assignment 3 and assignment 4. So what we're going to do next week is we're going to start with intro to data science with pandas, series, and data frames. I'm going to continue from slide 42 to slide 70. And what this does is it's going to talk about this. I recommend reading ahead. There's some really great stuff that you can do with series and data frames. And what it does is it expands on what we do with NumPy. Okay, so if you look at NumPy, one thing to note before we leave for the day is, what about if I wanted to import pandas? And notice that pandas for me is available. It should be there for you. If you can't see pandas here, that's bad. Now, I may not be able to import other stuff. Let's say, for example, if I want to import KRS, right? Notice KRS, I have it installed KRS with pip, right? So I can't import that. But anything that you can do, you should be able just to put in whatever you like. For example, we did NumPy, we did SciPy, we did scikit-learn, right? Scikit-learn is something that we included, right? sklearn. We did a bunch of other ones. Anything else that you've added in, matplotlib, you're going to see it here, right? But if you don't see something like KRS, right, which is another library that depends on NumPy, then you need to install it with pip. Okay, so now one we're going to talk about is pandas, and pandas we can do as kind of a data frame with pandas, okay, which we're going to talk about next day. All right, so that's all we've done here. We've talked about doing calculations, and this is great because once we can do this kind of work, again, this is purely with numbers. You can do a lot of stuff, especially with matrix calculations. If I want to do matrix kind of multiplication, hey man, NumPy is for you, okay? And we do a lot of matrix calculation when it comes to computer graphics, right? Specifically, we want to do the model view projection matrix for computer graphics in 3D. Take a look at that. If you want to look at the MVP, so model view projection matrix, model view projection matrix for computer graphics, right? It talks about how to convert, a 2D screen to look like or to act like it's 3D. Okay, so it's really kind of interesting how that works. Model view projection, MVP is what it's called. Right, and it's in order for us to do this, we need to multiply matrices together in order for us to get this model view projection. Okay, so again, they talk about that in detail in terms of everything from clip space, as an example, into screen space. Okay. All right, so that's it for me for today. I want to talk about this. Let's put this up on GitHub. This is my final version of my code. Again, we didn't do a lot of examples here today, but it's all around understanding NumPy. Why? If you understand NumPy, my friends, and pandas, those two libraries, man, they're the most common libraries you'll do with machine learning and data science. There's nothing else. And if you don't understand those in matplotlib, then taking a machine learning course in the future is going to be hell. I can't say that in any better way. All right, so now that you've seen some of this stuff, you're going to be in a better position if you're interested in taking machine learning or doing data science in the future. All right, let's put this up on GitHub. Git add dot. We'll say git commit -m, and we'll say demoed a range reshape, and what else we did? And universal functions, ufunc. Git push. All right, and that did craziness. What happened there? Did it actually work? Let's check up on GitHub for us until we end the day. And I'm going to take questions after this, so hang out if you have questions around assignment 3. I'm here for you, or assignment 4. Yes, it worked. Okay, so that's what this is. We're good for today. I'm just going to exit my VM, release some resources back into my computer. Oh yeah, it's acting really wild. I love when it does this kind of stuff. It's like whenever I do some really weird operations, like it's some kind of number key combination that I'm pressing. It's interesting. Power off. It's a wonderful day. All right, so that is what we talked about. Any questions before we go? Again, I'll stick around for any questions around your assignment 3 after this. So if there's no more questions, thank you so much for being part of today. I'm going to stop recording now, and I'll take questions related to assignment 3 after this.